a tradition, or have had the last couple of years, to have a friendly debate, or a shootout, to put it in slightly more violent terms, between a couple of people on an interesting topic of the year. And this year, it is the Open Cloud Shootout. I have been criticized today for the type of clothing I wear. The last shootouts I've been wearing a black and white striped referee shirt in order to be then able to stop the guys who are fighting too much with each other. For this year I made a slightly different preparation given the meteorological implications of the debate. So in my native Finland we have rain sometimes, and the way we prepare for it is we have a hat like this. But then on the other hand, I think it doesn't increase my long-term credibility, so I think I will refrain from wearing it all the time. So Duncan, thank you. So, to repeat the idea of the cloud panel, for those who haven't seen previous shootouts, the panelists get up on stage here, one at a time. We chart out the basic meteorological implications of each of the panelists. I have a question for each of the panelists, and I have given them the night to not be prepared for what kind of questions I ask, so they won't know what I will be asking them. And then when everybody has come up on stage, the friendly chat will begin. For the first time, we will now also have, I hope, the possibility for the audience to participate. So towards the end of the presentation, we will have a twittering opportunity. If you go out on the #cloud, or if you Twitter a comment on #cloud, it will be shown on screen, and I will then pick selected questions out of those. And the #cloud channel obviously also exists already for other purposes, so don't be surprised if you see other comments there. So without further ado, let's have our first cloud panelist come up on stage, and that is Lew Tucker, Cloud CTO from Sun. So, Lew, I know what your favorite question is, not what's your definition of the cloud. So I will be asking you something else. What does Sun do for the cloud? Is Sun some kind of a rainmaker?
I think we want to be the sun emerging from behind the clouds. What we're really doing with the cloud initiative at Sun is this summer we will be opening up a public cloud modeled along the lines of infrastructure as a service, so that our entire developer community can start to experience the cloud and go forward and develop actually, I think, a whole new set of applications. Some of the more interesting parts of cloud computing.
There's a limit of a total of 30 seconds, and I think we're at 27
Did we
now.
reach it already? Okay. We'll talk more.
Thanks, Lew. So,
bam!
our second panelist, Monty Taylor, MySQL Drizzle geek at Sun. So I'll give you the benefit of already in advance knowing that it's 30 seconds the limit. And my question to you is very complicated. What is Drizzle?
In 30 seconds. Drizzle is a fork of MySQL. Drizzle is also a form of rain that happens predominantly in Seattle, where several of us are from.
And I think, yeah, well, let's say that you used all the 30 seconds already.
Awesome. Fantastic.
Panelist number 3, Jeremy Zawodny, MySQL hacker at Craigslist. So for you, my question would be, is Craigslist a cloud provider or a cloud user?
Right now, we're neither.
What are you doing here? How did he get
Very, very efficient answer. You could have used more than 30 seconds in the beginning because it's saving up.
We try to be efficient at Craigslist, though.
It seems you succeed. So our following panelist is Chander Kant, CEO of Zmanda. So Chander, this is your opportunity to do a 30-second shameless Zmanda plug without paying for an ad.
Well, as shameless as it gets. Zmanda is in cloud backup space. We mean two things: backup of your data to the cloud and backing up of your applications running on the cloud.
Wow, that looked rehearsed. Very good. Our following panelist, Thorsten von Eicken, CTO, RightScale. Impressive entry. So, given that you might have had hoped for the same question as Chander, you have had some more preparation time now to think about your answer, but you have the same shameless plug opportunity.
So RightScale is a cloud management platform. We're really an on-ramp to the cloud, and we work with a lot of customers that have deployed on Amazon EC2 and run production deployments, almost all of which use MySQL replicated databases.
Thank you. So I see still some open chairs. This means that our following panelist is Prashant Malik, a Cassandra dude at Facebook. So I thought Facebook was a social network. What is Facebook up to in the cloud, and what is a Cassandra dude?
Well, Cassandra is a next-generation structured data store. If you put it simply, it is a marriage between Bigtable and Dynamo from Amazon. And we believe it will be the database of the cloud.
Okay, thank you. For our final chair, we have Mike Culver, evangelist with Amazon Web Services. So, Mike, what's your weather forecast for Amazon in the year to come?
Completely cloudy.
Okay, so now for the question that Lew has dreaded. What is a cloud anyway? And anybody of you may pick up the mic.
So I'll pick that one. I think actually in this context where most of us like technology and don't think as much about business models, for me the most significant part of a cloud is the automation. It's a fully automatable computing infrastructure, and I think that's really what affects databases, applications, that you can completely automate the provisioning, the scaling of all of the resources, compute resources that an application or that a deployment requires. And I think that's really what's exciting to me and new. It changes the way I operate deployments, production deployments, because I can really now automate everything I want to automate, and that's always what I want to do. Saves time, saves cost, and it also increases reliability.
Further answers. Anybody who puts the microphone close to the mouth may answer.
Okay, I think one important characteristic here really is elasticity. I think one of the reasons why cloud is so interesting is that even a small company can shoot for the moon without shooting themselves in the foot.
And to that point, I think that one of the attributes of the cloud would be that the automation is accessing a pool of resources that, while it's probably not infinite at the end of the day from the point of view of any individual organization, it's just basically this on-demand, what appears to be infinite pool of resources that you can tap as you need it.
It reminds me in that way of other utilities. It's sort of like the turning of computing resources into a utility, much like electricity or network bandwidth at this point. You don't really typically think of, ooh, I wonder if the electricity company is going to run out of electricity if I need more and my neighbor needs a little bit less, although it happens sometimes here in California. But in general, it's applying that same model to computing and computing resources.
I think Monty's on the right track. We're talking about what a cloud is, not what are the benefits of a cloud. And to me, it's really two things. One is it's virtualization. We didn't have good virtualization technology a few years ago. So it's that and the combination of pay-as-you-go. You put those things together, and you've got cloud computing. All this other stuff on top of it, automation and infinite scaling and things like that, are things that some cloud providers are promising, but they're not necessary pieces of the cloud.
Yeah, I would completely concur, because I think we're seeing that it's not so much new technology, but it's a new way of delivering the technology and packaging it up with a pay-as-you-go model. The high degree of automation means that applications themselves can do provisioning. So we finally, for the first time, as a developer, you get to provision your application through the code itself. You don't have operators you've got to go through for anything else. So God forbid we might see Skynet someday happening, but if we can sort of stay away from that side of it and really make applications much more flexible, I think we'll see a whole new class of apps being developed as we move forward in cloud.
And so let me ask a slightly more specific question here. Do you see different types of clouds? I mean, Google is that kind of a cloud, and I'm being educated here, but I'm still confused, I have to say.
I think there's been lots of talk about different kinds of clouds, but also the different layers within the cloud. And that's where we see the infrastructure layer that Amazon has shown so well with AWS. But then we also have platform as a service, which is much more kind of Google app. And then you have software as a service application delivery at sort of the top level. So there's layers in the cloud itself. And then there's also, I think, we'll see clouds that have been optimized for different things, such as high-performance computing, video, streaming, things like that.
Okay.
And storage clouds.
Yeah. Sure. So who then is the cloud for? Is it for a developer? Is it for a user? Is it for a company? Is it for the CEO or CFO? Or who is it directed at? I mean, who is the cloud for?
It's for you.
Thank you.
So just going back, right, in 2006, Amazon launched EC2, and 2006 it was really just for weird folks, was for geeks. Nobody really knew about it. It's like 2007 we went around to get funding from VCs, and we got a lot of looks about that's just Jeff Bezos' experiment. When is Amazon going to shut this down? And Thanksgiving they're going to need the machines, the excess capacity is going to disappear. 2008 a lot of people woke up, and a lot of Web 2.0 success stories started to come out. Large organizations were still largely ignoring the cloud. We saw a lot of business line owners that, I can't get this server from IT in any reasonable amount of time. Guess what? I'm just going to put my credit card in and be done with it. I think now 2009, we're seeing really top-down from CIOs that are looking at their budget or lack thereof, really, and are asking director of operations and other people in the organization to go out and explain to me what the cloud is, how can we leverage the cloud? So I think the who is the cloud for is becoming just about everyone at this point. It crosses organization sizes, it crosses different industry, crosses verticals.
Mike Luxiger.
So I think that Thorsten was right on the money there. I'd add on that I think that it's really a horizontal technology opportunity, I think, for most organizations. And to move in, I agree with everything that Thorsten said about the adoption curve and what it looked like. It started where you'd expect. It always starts there. But now we're starting to see mainstream applications move into the cloud. And I'm talking by mainstream, I mean both from mainstream ISVs as well as line of business 24/7 apps. I was on a webinar yesterday with a company that runs ERP in the cloud, and I was amazed at the number of attendees at this webinar. So the interest is up there, and the adoption is up there as well.
Yeah, so I think talking about ISVs, I think clouds are definitely creating a platform for ISVs like us to innovate much faster than we could have. And frankly, being in backup space, one of the things that cloud has done for us has made backup suddenly sexy. I mean, it is easier for us to hire developers. It used to be the case when I would talk to journalists about backup. Even if I spice it up with the words like open formats and open standards, they would still yawn. And now, I get invited to these shootouts, and even though I'm still running a backup company, I am expected to be entertaining.
I think a lot of the cloud technologies is, as other people have said, meant to be for everybody, but we have to go back to the utility analogy. A lot of people think of what they want to do and not the technology enabling them to do that. We don't look at that plug in the wall. Okay, at the conference we think about powering our laptop, but most people think about just plugging something in to get a job done or to watch TV or whatever they're doing. And we don't think about the fact that we're tapping into this power grid and all the pieces behind it and things like that. Right now we're kind of in that phase where we still think that way. And worse yet, we're in a phase where the power outlets are all shaped differently and the plugs don't all fit into the same outlets. So the technology hasn't matured yet, and we're not to the point where you can just pick up anything off the shelf and plug it into that wall or plug it into that, that faucet or water outlet or whatever it's going to be. And I think as the next few years go by, we'll see that standardize, and people will use the cloud not even knowing or realizing what a cloud is, and that's where I think we need to go.
And then for the end users, I think that because when we say everybody here, I think a lot of those everybody's are the everybody's that are in this room and other rooms like this room. For people like my mom, hopefully she'll never notice that it's there, but she'll notice that she's always able to get to Wikipedia when she wants to know what Bovril is. Or when I do, never mind. But yeah, I think that's the important thing is keeping that always there for people.
Cloud is also about data. Basically, all the data is moving to the cloud, not only from individual users, but from enterprises or from small and big businesses. And it is not only about putting the data there. It's also about sharing that data with whomever you want to, with trust relationships and stuff like that. And that is where the cloud is also evolving into.
So my next question, you've partially already answered, but I have some more specifics to it. So the question, why use the cloud, I would want to make it a bit more specific, looking at, for instance, legacy applications. If you have an existing application, how does it benefit from the cloud?
Well, I think that a lot of things, and you'll see the popularity, especially at this conference, of things that have to do with scaling your applications and making things be able to deal with the fact that maybe you woke up and all of a sudden you have Facebook-like traffic, and this is a terrifying thing to you all of a sudden.
But Facebook is not a legacy app.
No, they're not. But as you're working, who knows? One day and it may not be legacy applications that benefit from this immediately as much as people doing sort of new things they're expecting to scale. I think that maybe if you're doing a back office payroll system, that maybe putting it on the cloud today isn't the first thing you might want to do. But if you're providing a service for lots of companies to run their payroll through your system, and you might become successful, then instead of you having to find the 5 smart engineers out there in the world who can figure out how to really scale that, you can leverage a collective of those people who are already doing it. And then you can focus on making a payroll system for people rather than focusing on engineering the scaling of a system.
So can you move part of an application or onto the web? Can you use it just in part?
Sure. I think a lot of it, though, depends. I mean, by definition, legacy applications are the applications that were built for a previous architecture and a previous set of needs. And if they don't have the kind of scaling requirements, they're probably going to stay where they are. Fortunately, cloud computing is based on virtualization, so enterprise companies that are already going through server consolidation by virtualizing their infrastructure, they can start to envision legacy applications moving up that virtualization ramp, and then the next thing, now it's being provided by some other outside provider and now delivered over the internet. But by and large, I think legacy applications instead will be replaced by the new applications that are going to be solving the same problem, though, in a new way.
Yeah, we found at Amazon that there's this low-hanging a set of reasons why people are really interested in I guess I'll call it forklifting an application into the cloud. And probably the biggest reason is that people just want to get out of that cycle of trying to find data center space if they're doing a colo, or arguing with the data center manager if it's in-house, and taking care of all of that infrastructure that's really not adding any value to their business. And if they can get out of that cycle, they can pay attention to other things that are more pressing. But I think that in the recent months, what I've seen is we're seeing more and more enterprises moving into the cloud, is that what they're able to gain with the cloud is a level of durability and resilience, because In the cloud, you're able to, for example, in the case of servers, select which of several data centers you want to scatter your servers across. And that may not have been an option in the traditional IT infrastructure where you only had a single data center. So it's that class of reasons that make it a very attractive value proposition for folks that are thinking about making a switch.
I'll actually argue that the legacy applications that you specifically asked about, I think, are easiest to move into the cloud, because one of the things we think a lot about in this crowd, I think, is scaling and performance. And legacy applications, in my mind, are best understood. They've been around a while. People have been using them. They've been supporting them. They know what kind of hardware they're used to running them on. So you can pick from a list of servers, size up what you think it's going to run on. You're probably going to be right. And you have a good sense of what the demand is going to be. You know, you compare that with something like Facebook, which is not a legacy application, and what are they going through right now? They're going through, you know, crazy growth spurts, you know, one after another. And that's a lot harder to scale when you've got many layers of abstraction between you and the hardware, and you don't know what else may be competing with you, what the infrastructure looks like. That's probably a big reason they own their own infrastructure and operate their own infrastructure, versus taking some in-house ERP system or accounting system and slapping that on EC2. I think the two are very different, and people should be a lot more comfortable taking something they understand and putting it on infrastructure that, for the most part, they're just picking from a list of things that look kind of like what they're used to, different classes of servers.
So Facebook has been very lucky in having this growth, but it is also at the same time very painful to go through this growth and scale. Cloud is the right approach, probably a dream, but it is not there yet. Slowly we will have applications which will be more and more like Facebook, and maybe even show even more growth than Facebook has. And these are the applications that the cloud can probably support. Even traditional applications, for example, if you take some things like QuickBooks or stuff from Intuit, could probably be moving to the cloud. And that is the direction, I think, in which the users of cloud would be.
Yeah, so at a very different level, now I operate machines, I operate deployments, and for me, a big part, all of this I would agree, a big part is just flexibility in development and test. So when be able to have my DBA clone or set up another slave server with exactly the same hardware, the same data as to production, in order to test out schema changes ahead of time. So he actually knows how long they're going to take, when we're going to be down in order to do an upgrade, and then pass this back and have a developer that's responsible for one of the migrations that takes longest, and pass it back to him and have him fire up another clone of the production system for a day or two in order to actually optimize that change and bring it down to a reasonable amount of time. That's just flexibility that I didn't used to have, because I just didn't have a bunch of machines all with SAN ports and with additional SAN storage arrays just laying around for the odd day or the odd hour where we wanted to make a copy of the whole thing and try something out. So that's a very different level where I think the cloud is extremely powerful and really saves us a lot of time and a lot of headaches.
Yeah, and it allows you to do that even if you're, like you said, if you don't have lots of hardware running around, or you're working on something where you only occasionally need little bits of hardware. One of the developers at Canonical, one of the guys that works on the Bazaar version control system, just wrote a thing that when they're running their test suite, will spin up several EC2 instances, run the test suite in parallel, and then spin them all down. Yep. And if they do that once every couple of days, then they've paid like $1 for like 12 machines, and that's fantastic.
Yeah, and we do that with our server templates. We have automated, it spins up a whole deployment with 10 servers, database, app servers, and put some load on it, runs some sanity checks, and shuts it all back down. It costs $1 or $2, and you have a whole complete test of the whole stack.
So that's one of the most, I think, the real hallmarks, that we are actively driving down the cost of computing. Mm-hmm. And we're making it so affordable to do these experiments, to look at a lot of the processes that we run today and think about them very differently, because now the cost can be 10% of what it was before. And contrary, when we've seen that happen in the industry, the use of computing actually grows. I mean, it grows much faster than actually the cost reduction.
Yeah, I like your growth, because it's, for me, I'm always hesitant when people think, oh, I'm going to save money. I don't know whether we're saving money. It's just we're using it as a tool, right? Being able to spin up the servers, use more servers in order to solve problems. And to me, that's more valuable than trying to say I'm going to squeeze the cost a little bit.
Thorsten, I think you have always talked about, having 1,000 computers running for 1 hour. the same cost actually for one computer running for 1,000 hours. So if you want to have something done right away, you have the time advantage of using those 1,000 computers. You can do that with cloud computing, and you can't do it in any other system I know.
There's also a real green advantage too, because you've got, if I in a traditional infrastructure wanted to have a lab with 20 test machines in it, then they're going to be sitting there consuming resources at times that I'm not using them. If I can put those back into the cloud so someone else can use them, that's even in a different organization, then we're able to share and have that be more efficient for the world in general, which is just really, so it's about saving the world.
Can you save the world in a shootout? I mean, I see people nodding here. This is not nowhere nearly as violent as a shootout is usually supposed to be. So let's see whether the following question will get some heads moving in the different direction. So I'm looking for cloud adoption barriers. For instance,
data privacy.
If you're running money laundering and you're afraid that the government is going to come in and see your books, if you put your data, say, in your Gmail account, then the government asks Google for it, they might give them it. Whereas if you had it in your own servers, you could put them in a bag and go to a different country. So I think that's important to some people.
Answer.
I mean,
that doesn't scale particularly well, however.
I think in some cases, performance is going to be an adoption barrier as well for a while. I mean, just the other day we had a request for a refund where one of our customers was trying to shove a terabyte of their data in an hour to S3. And we kind of tried to explain to them that, their data between Kansas and Washington goes through various towns. But we didn't go much. So I think, especially in US, we are about 6 megabit a second. That is kind of the affordable range for small and medium-sized businesses. It needs to get up at least an order of magnitude before some of the storage clouds become really successful. And I do believe that will start to happen. In fact, some of the provisions in the latest stimulus bill will take us there. And some of these provisions are actually bridged to somewhere. And one of them is success of cloud computing.
I mean, we've had to move the compute to the data for decades now, right? So in a way, the compute needs to move where the data is. Maybe you're talking about a one-time import problem.
Well, I think storage clouds have a slightly different notion than compute clouds. I think, depending on the application you're using, today most businesses will find themselves to be bandwidth or latency limited unless they have a very specific use case of how they will be using storage cloud. So I think going back to the previous question, why use cloud or where use cloud, I think a customer always needs to also consider where not to use a cloud and have their expectations somewhat checked when it comes to trying to push a lot of data en masse.
You already have a preview of my following question, so I've seen hints at answers here already at the question, what applications fit best for the cloud? Jeremy, you were saying that's the legacy apps. But what are the ones that will never move to the cloud, and why?
Some of those apps are going to be financially sensitive data that a company does not want to leave its walls, probably just out of fear more than anything else, because there's obviously ways to safely transmit encrypted data and information and things like that. But there is a psychological component around owning your own data or owning your own data center that I think is one of the biggest barriers right now to adoption.
Yeah. Certainly trust and privacy is number one issue, and it's mostly education. I mean, whether you're shipping data on tapes to a remote location or shipping data on wires, I think risk is about the same. In fact, I would argue probably risk is more if you are shipping physical media. But I think educating the users on technologies like encryption is going to be the key before some of them adopt these technologies.
I think a huge barrier to adoption right now that no one's really talking about is competition. I mean, we have a rep from Amazon on stage, and I think they've got huge mind share and a huge lead in cloud computing right now. But until we've got Amazon and Sun/Oracle and Cisco and Microsoft and other companies battling it out and really driving the price down and making it easy to migrate from one service to the other, whether the standard is the Amazon machine image or something else, people are going to worry a little bit about lock-in, and they're going to worry about the viability of this computing model if it's Amazon as the behemoth, and then some other smaller traditional web hosting companies trying to get in the game as well. Because right now it looks a little, I think to a lot of people it looks a little sketchy. It's like that might be the future, but I want to see a little more there. And we've heard things. We've heard things from Sun. We've heard rumblings out of Cisco and other companies. But let's see it. I mean, where is the competition right now?
Lock-in is definitely a big topic, and we've gone live with several large enterprises who had to have some DR set up somewhere else, and that was really a struggle in order to make that happen. But it is happening. There's definitely lots of smaller companies, efforts at Sun, Rackspace, and many of the telcos are trying to understand how they get into the game. So I think the multi-cloud and having multiple providers is definitely happening.
So Jeremy already hinted at this question. Are there cloud standards, and will there be, and what will they look like?
I think that in large part we have standards today because we're based on, I'm just speaking for Amazon here, we're based on open industry standards in terms of the servers and the operating systems, that if you decide that your application that's running on Fedora is not going to continue to run in the cloud because for whatever reason that it doesn't make sense for you, that you can move it someplace else and it still runs on the same OS. So I'm not certain that, I know there's been a lot of industry buzz about standards and especially about lock-in recently, but I'm not so certain that there's really a deep-rooted concern out there in the user community because
we absolutely do need some notion of standards and way to operate across different clouds. I think the biggest debate is what should those standards be about, and the API is, in my mind, not necessarily the most important level in that. What the call is to launch a server, well, big deal. It's a programming exercise. I don't want to do it 100 times, but that's what it is. But what is a server? Can I hibernate it? Can I stop it? Can I restart it? Do I launch it from an image, a sort of template? What is a storage volume? What's a disk volume? Can I mount it, unmount it? Can I snapshot it? Can I mount it to servers across data center boundaries?
So I see a starting point for a disagreement here. So
and these are really important questions because if your recovery strategy or failover strategy means, I'm going to unmount those disk volumes here and I'm going to remount them over there in that other server that replaces the one that failed, and then you discover, the other server is in a different data center and I can't mount the disk volume. Oops. Suddenly your whole architecture and your whole strategy breaks apart and you get to redesign. So having some way to think across the different clouds or standardization at that level is really interesting.
That's talking more about a standard of what is a virtual computer and what are the expectations that you have in terms of the operations you can perform on that computer. And I agree with you because a lot of what we're calling APIs and standards today have to do with interoperability. Can one application talk to another? And I think we're doing very well there because we've got some great communication standards, TCP/IP. When you get into the level of management and what is a server and what are the actions, I think that's going to be a lot harder. And it's way too early for us to actually, I think, start trying to lock those things down. Instead, I think we should be thrilled about the fact that right now we're in an age of expansion and experimentation, and we should really see what these models hold before we go too quickly towards standardization.
I totally agree. I think that a lot of these will wind up being more emergent standards as people use them, and I think there's actually a real that there's a big potential downside to premature standardization. Yes. And there's, I think, been several instances in history of computing where people have jumped on standardization too early, and it just it kills her because all of a sudden there's this 700-page thing from some working group that everyone has to implement, so no one does anything.
I completely agree. So I think open APIs and open standards are definitely a key for success here. I come from storage world, and we can't live without open standards in this world. But before somebody throws manifesto on my friend Mike's face, I like to say that S3 created a standard of its own. Frankly, when Amazon decided to write an unambiguous API, which definitely has quirks, and I can talk about those quirks at a later point. But by being the first successful open API, which didn't have a lot of ambiguity, it actually fostered a huge amount of innovation. And this was not actually an obvious decision on Amazon's part, I think, because just a few years ago, there were all these storage service providers which kind of tried to provide the same concept without an API, which basically tried to do too many things on their own, and they basically fell on their face. And suddenly S3 came in and made storage clouds a reality, and all of us are on stage today.
It just goes
but
to
at the
show
same
that
time, they're not making it available in the sense that they're not making it easy for others to adopt that API. So it is not an open API. It is not a free API that you are free to copy and make your own version. And so while I agree with you that, yeah, they created the standard and it's a good standard, all of the APIs coming out of Amazon are by and large very good, which is really a great help to all of us in the cloud computing community. But it would be doubly nice if they were actually free or open or whatever the right word is, so that others can implement their version or their underpinnings of the same implementation of the same API.
Mike, do you agree?
Well, I would say that if you think about standards, if I were the person who was looking at what decision to make, I would actually be thinking about what's behind that API. I don't believe that if there's an egalitarian API for the world, that it's actually equal. It's operational excellence in web services that matters. And by that I mean, if your web service that you're relying on to run your business is down, or if performance is not what you expected or what you signed up for, standards really don't matter.
So I would totally agree with you that the operational excellence is really what makes the hallmark, and so make the API freely available to other people. And I think a lot of other people are finding out it's actually not that easy to put up an EC2 and
I would
open it
have
up.
to agree with you that,
there's no Eucalyptus, so in a couple of days you can download Ubuntu and Eucalyptus and set up your own EC2 in your own basement with your own little servers. You can register it with RightScale. But we're going to find out how hard it actually is.
As we heard down the row here, when you're innovating at a very rapid rate, it's very difficult to establish standards and get everybody to agree on them without completely slowing up the rate of innovation.
Maybe the first step there is, I think Thorsten's saying, is that you make APIs open and freely available and be used. I mean, that's one of the things we tried to do with Sun by publishing the standard, our API, under Creative Commons, saying that anybody can do with it what they want, because that gives them the freedom. They can implement it, they can compete with us, and they can do a better implementation, because that's how you're going to drive service excellence, when you can agree upon here's a way to do something and you compete on the implementation.
Yeah, so certainly I think some of the initial standards don't need to come from committees with cool sounding names. I think some of it is industry force, and there is certainly a danger of premature standards. And we have been demoing our backup to the Sun Cloud here at the conference, and one of the exciting things that Sun team has done is to create S3 compatible APIs, which enabled us to quickly integrate one of our products with Sun Cloud. Now, another interesting thing that Sun Cloud team did was to also support WebDAV, which is actually which is a standard coming from a committee which sounds cool, Internet Engineering Task Force, and which allows us to participate in all the tools and utilities that are written which are compatible with WebDAV, which we could never do on our own.
Okay, so let's move on then to sort of, it seems, the flip side of standards, why standards are not being created. It's because of business opportunities of the individual players. So who can earn money on the cloud, looking at the provider side?
You can.
You must have a very good hand there.
I think that there's because it's a horizontal technology, I think that all of the existing business models for the most part work. But I have actually identified what I think is a very unique and compelling business opportunity out there. So if you think about how the cloud works, essentially what you're buying is infrastructure on demand, you pay as you go. So, 10 cents an hour for a server or what have you. But at least what we've made available through Amazon, and I expect that we'll see this model emerge elsewhere, is we have a service called DevPay, and essentially what you can do is you can install your software into a virtual machine, like an Amazon machine image, and set your own price per hour that you want to charge for this. So if you have a CRM app or some other sort of software running on top of that ERP, You can set your own price, and then what happens is the customer signs up for your product, and they actually pay through Amazon, and we send, we take out the underlying cost of the service and send you the difference minus the 3% commish. So it's actually turned into, rather than what I would call software as a service, I like to call it software as an annuity, because someone else takes care of all the billing, someone else takes care of all of the hassle of running the infrastructure, and you just have an ongoing revenue stream. And it sounds thin at the beginning, but if you think about how things work in this industry, it's actually a very unique and, in my opinion, compelling business opportunity. That's just one, but I'd call that out as a really unique example of cloud computing.
I think it also poses a big risk to certain companies. I mean, if you are a backup vendor whose business relies on writing to tapes and shipping those tapes, I would be very worried. I mean, as soon as 50 megabit a second or something becomes a reality, you can push a terabyte over a weekend, and suddenly, there is no use of tapes. So I think that there are going to be a lot of discontinuities in various businesses that cloud represents.
Prashant, you look like you had a...
Yeah, so there is a need for a database on the cloud also, which can take care of most of the failure scenarios that become more prevalent with the cloud. And this seems to me like a business opportunity, something that can provide this kind of reliability, scalability, and incremental nature, which is prevalent with the cloud space as such.
Yeah, I couldn't agree more that I think we're seeing an explosion in the amount of data and storage required that's growing much, much faster than the need for computing cycles themselves. But associated with all of that data then is the computing that you need to be able to do, to either store it, to analyze it, to do analytics on it, and everything else. So those things start to get coupled, but I think it's largely going to be driven by the storage needs. And so for this conference in particular, I think there's a tremendous range of opportunities, like you say, between Cassandra or Drizzle and these other things, as they start to turn into services available in the cloud. Those, I think, will be the most compelling business opportunities.
Yeah, I also think that you're going to see more and more mainstream household name ISVs move into the cloud. We're already seeing it. In fact, just today, for example, Sun announced that Glassfish and OpenSSO are available in the Amazon cloud, and I'm certain you'll see that happen across the industry as time moves forward. So I think that there's an opportunity to leverage existing ISV offerings and make a new business on this cloud model.
I think there's a lot of opportunity for independent consultants and smaller companies that want to get in on the technology early, learn the pitfalls, figure out how to do performance tuning and optimization. The same kind of thing that happens now on hardware you own when you're having database performance problems or web performance problems or whatever it might be. Turn around and do that for the major cloud infrastructure, and you'll have people banging down your door because they signed up for this great service and didn't quite understand how the performance might differ from the hardware that was sitting in their server room, and they're going to need to turn to someone for help. They might or might not be able to get the help from Amazon or Sun or Cisco or whoever the vendor's going to be, but they might want someone down the street or someone they can call up on demand and pay a little bit of money to help figure out the problem. And as you gain experience and as you gain a reputation in that, I think there's a great business there.
Yeah, and it also, I think, facilitates the traditional MySQL freedom to work from anywhere for a lot more people, as they realize that you don't actually need to go to the data center in the town that the company is in. So you can get a guy in Tennessee or wherever to work with your company who's based in LA, and have a guy in England also helping out. And that's really enabling for a lot of those people that are doing consulting work and providing services in that way. And I think that's going to be really huge for people.
And I think for bigger players, as the margins on things like hardware come down, cloud is a great opportunity for them. And I talked about Sun Cloud. I mean, various companies are making massive investments, including Sun. I mean, I think we'll have to take Lew out on a couple of drinks before we know when exactly Sun Cloud is going to ship. I mean, I think the reason why we have access, we are one of the few players who have access to Sun Cloud, and I think the only reason we have that access is because we got hold of some of Lew's pictures from last vacation that he had. I think
you weren't supposed to mention that.
I think he's still wearing the shirt from that vacation. So I think when, as Jeremy mentioned, that when more clouds become available, I think this thing is going to explode, and I think that starts to happen by end of this year.
So you mentioned prices and you mentioned drinks. So I know if you buy a drink, that's the unit of what you're paying for. But in what unit do you buy clouds? Do you buy it in gallons, or I mean, do you buy time? Do you buy transferred megabytes? Do you buy storage, or what? If I want to buy a cloud, how is it measured?
Well, that's where there's a huge chance for differentiation with other vendors. I mean, I was excited when Amazon unveiled their cloud services, but also disappointed because I thought I was paying for CPU time in terms of what I used, not how long the machine was running, whether or not it was doing anything. And I think you'll have people who would prefer to have machines that are always on but can sit idle and get charged at a lower rate. I think that in the case of storage-centric clouds, you're going to pay more for data storage or data transfer or data integrity. And I think you'll have cases where CPU-bound tasks may have clients who are willing to pay for higher priority or willing to pay less for lower priority tasks. This was some discussion that came out with Amazon's Hadoop service. Mm-hmm. It's like, well, gosh, this is great, but what if I could pay half as much and maybe the job would run only on idle time when other people aren't using their machines? And I think there's a lot of opportunity there to differentiate based on what's important to the person stepping up with the money. Yeah. And right now we've got just a very small set of models to choose from, and I think there's a huge chance to change
What's
that.
interesting, I mean, Thorsten mentioned automation, and that's really, we are replacing human systems with automated systems. That actually makes it more possible to slice and dice up the resource that you're charging for in many more interesting ways. And I think right now we have some very sort of first-level approximations for what customers want, but as they go forward, I think it's going to be much more exactly what I've used and charge me for that and be able to have that time-performance trade-off going forward.
Of course, it really amuses me that we're talking here about being excited about paying per CPU cycle and things like that, and that was sort of the mainframe model like 20, 30 years ago.
So it's virtualization.
So it's virtualization, and I guess the main thing we've got going for us is that we don't have to write this crap in COBOL. So,
although the size is not fixed, right? On the mainframe, the size of the box is pretty much fixed, and it takes a long time to add anything. With the cloud, the cloud is sort of the mainframe, but it is so much easier for the infrastructure to scale and to be built out incrementally and to keep expanding.
That's where we are seeing the data center is becoming the next computer. So that's mainframe class size computer that we can start to use.
I thought the network was the computer.
It keeps changing, but what actually we're going to start including now are the loading docks, because anything that is continually adding physical resources is going to have to be present in a cloud.
I would be remiss about adding the loading docks, or else we're going to have to talk to Teamsters.
I would be remiss if I didn't point out that you can run mainframe COBOL applications in the Amazon cloud.
Maybe you can.
I think that we might have to see some bloodshed.
No, there is actually. No, seriously. There is actually somebody who put a mainframe emulator up in
COBOL will live forever.
That's just too painful, so my brain is now bleeding.
So I do think billing is a major challenge here, and I think that's actually one of the reasons why storage clouds actually have done better than compute clouds, because their billing is very clean. Basically, you pay for bandwidth and storage, and I think that's probably one of the reasons why all cloud vendors tend to ship their storage clouds before compute clouds, because they have figured out how they're going to monetize it.
Yep. Okay, so I have one more set of questions before we open up for the Twittering questions. And you have actually answered my cloud competition questions already, so I would go for the database. So how do databases map onto the cloud? What's the role of databases?
It really changes the way you operate databases in the cloud, in that just the flexibility in always moving to the next server, to the next disk volume, changes the way you think about both doing testing and firing up new slaves, firing up new databases in order to try things out. As well, when there are failures or something weird is happening on my master, let me just fail over. I don't need to worry about the thing that is misbehaving. I can launch new slaves. I'm again in a replicated or redundant and scaled out setup, and next week I can go and figure out what went wrong so that I can fix the bug if there is one, and it doesn't repeat. So just this amount of flexibility one gets in operating databases is just so refreshing if you've ever lived through having a limited number of sand ports and spindles and machines in the front end.
You pretty much have to start out thinking of like m times n problems. You're never really, if you're thinking about a cloud, you can never think about there being one database instance so much as there may be more. There will be, x equals more than 1 for all of them, and you may have another set of databases that also are more than 1. And so you're always having to start thinking about the multiplicity of that and how you're going to deal with that things. But that makes, once you figured out x equals more than 1, then it's just a matter of putting more than 1 in there.
So I have a screen here in front of me that you don't see, and it says that we should be ending now. My idea was that we would continue until 10. Am I wrong or am I not wrong?
You're wrong. Oh.
Okay.
Well,
so
we're not leaving.
Thank you for all your Twitter questions. I have prepared lots of other stuff. That's fine. We're done with our cloud. Thanks to the panelists and thanks to the audience. And sorry about this twittering not working. I see lots of questions there. Can you read them?
No.
How about 60 characters instead of 140?
Okay, so I can see that for the next year I have to get a bit better glasses in order to be able to do the twittering stuff. So thank you anyway, and thank you, panelists.